Hello and welcome to the NanoAvionics broadcast of the SpaceX Transporter-6 mission launch. My name is Sharunas. I'm the content manager at NanoAvionics, and I'm joined by my colleague Karolina Juknaitė, who is our systems engineer today. And the launch is scheduled to take place in roughly 30 minutes time. So thank you for joining us, where as a small satellite mission integrator and small satellite manufacturer, we have 4 customer satellites on board the SpaceX Transporter-6 mission today. We will only be talking about 3 of these satellites, since the 4th customer did not want to be disclosed for this launch. And to give you a sense of how this event is going to take place, first, we will take 10-15 minutes here in our studio to get you on board with the missions and our satellites flying on board the mission today. Then, once SpaceX goes live with their live stream, we will switch over to their broadcast to see the countdown of the mission and hopefully a successful launch to orbit by the Falcon 9 rocket. At that point, the Falcon 9 will enter its coasting phase for roughly 45 minutes, at which point we will come back to our studio here to hear a little bit more from our clients on both of their missions. We will also take that knowledge we've learned from them and test it in a quiz, where you will also be able to join live and win some prizes. Finally, if you are interested in working in the new space industry on some cutting-edge commercial satellites, and if you have any burning questions about starting your career in space, we will have our talent acquisition partner join us to answer any of your questions and talk about what it's like working at NanoAvionics. So if you have any questions, please do leave them in the chat, in the YouTube chat, so we can answer them. If we don't have time to answer them all, then hopefully some of our colleagues behind the scene will be able to just type them in for you and get your answer there. Then we'll be through the coasting phase on the Falcon 9 second stage, at which point the SpaceX broadcast will return, and we will switch over to it to watch the satellite deployments, which should take around 10 or 15 minutes, at which point we'll come back to the studio for sort of a final celebration, fingers crossed. And also we'll have one of our satellite operations engineers to guide us through sort of some of the first steps in contacting and operating the satellites, since when SpaceX's mission ends, ours basically just begins. So that is the quick rundown of the event. And now I'd like to turn to my colleague, Karolina, and maybe you could give us a rundown of some of the highlights for this mission today.
Of course. Hi, Sharunas. Well, first of all, thank you for having me here. So first highlight of today is probably that the launch itself is actually the first orbital launch of 2023 in general. And one of the satellites we're launching today is actually the first European solar sail mission. So we're starting the year with actually a great start. And I guess one of the personal highlights is that one of the satellites we're launching today is actually the very first satellite that I was personally working on. So it's a really exciting day for me as well, and a really special launch. So I probably would like to use this opportunity to say to whoever is watching us today, hello everyone, that if you would like to share this excitement, maybe start next year, the same excited as me, just go to NanoAvionics careers page and probably you could join the team eventually.
Okay, well, thanks and congratulations on the milestone.
Thank you.
Also, 2022 has been sort of quite a huge year for space in general, and looking from our perspective, what are we looking for in 2023?
Yeah, of course. Last year was really good, and this year is going to be even bigger. So one of the main milestones is probably that this year we're planning to launch and deliver over 20 satellites. And also we're launching our first satellite that's heavier than 100 kilograms.
Okay, so we didn't have a table strong enough to handle a satellite that heavy at this launch. But speaking to that, maybe you could guide us through the sizes of the satellites that are launching today, actually.
Of course. So the sizes range from a loaf of bread to a size of a shoebox. So as you can see, the 6-unit satellite over here. So as you said, one of the clients did not want to disclose the mission, but all I can say, it's an Earth observation satellite. And as for the other 2 missions, the satellites are of the same size, but the missions are really different from one another.
Okay. Can you tell us how do they differ from one another? Or do they have different subsystems aside? I mean, apparently they have very different mission requirements.
So the general architecture is quite similar, but as you said, some of the things differ due to the requirements and objectives of each mission. So compared to Gama Alpha, the Milspace 2 satellites are equipped with electric propulsion system. They also have a star tracker and an X-band transmitter each. So as you know already, I don't know if everyone here is aware, the Milspace 2 mission is actually comprised of 2 satellites. That's Huygens and Birkeland. And those 2 satellites will be flying in a 20 plus minus 5 kilometer formation. So in order to maintain that close proximity and maintain the formation flight, you need a propulsion system of some sort. And for accurate attitude determination, you have a star trackers on board, and then X-band is used to achieve significantly higher data rates compared to S-band transmitter, for example. So due to the nature of Gama Alpha mission, it doesn't really need all of those things because the main objective of the mission is to test the solar sail deployment, and once the solar sail is deployed, it will already be considered as a mission success.
Great. So yeah, just to summarize, the 2 of the missions that we're going to talk about today is the Gama Alpha mission. Gama is a French company looking to build solar sails for the commercial and research organizations who want to explore deep space using solar sail propulsion and not having to carry a lot of fuel on board. So this will be their demonstration mission of basically demonstrating their solar sail deployment mechanism. And the Milspace 2 mission is a consortium of Norwegian and Dutch research centers, FFI, TNO, and NLR, who are looking to measure and classify radio frequencies here on Earth and geolocate signals. So you mentioned that the Milspace 2 mission comprises of 2 satellites, Birkeland and Huygens. Why did they need 2 satellites, and why the formation flying approach?
So I guess the question itself answers the question of you cannot really do a formation flight with 1 satellite, right? So that answers the 2 satellite question. But generally, the Milspace 2 mission, as far as we know, is the first in the world 2 satellite system to detect, classify, and geolocate radio frequency signals by implementing a formation flight. So because satellites fly in formation, they'll be able to detect those RF signals simultaneously. And since we know the precise location, position, and attitude of each satellite at a point in time, the client will be able to combine the measured signal angle of arrival and the time difference of arrival between the 2 satellites. So that's what would make the precise geolocation possible.
Okay. So they're basically building one giant 20-kilometer size satellite
system,
to geolocate those signals. Okay, and switching over to the Gama Alpha mission, is there anything special about it apart from being the first European solar sail mission in space?
So we already know that the size of the satellite itself is 6 units, just a small shoebox. But the deployed solar sail has an area of 73.3 square meters, which is comparable to a 2-bedroom apartment. So this is a really large material. The whole thing fits into a cylinder of approximately 20 centimeters in diameter, but you can imagine that the polyamide film has a thickness of 2.5 microns, so it's a really, really thin material. And of course, that imposes some challenges when handling it. So actually, the Gama team told us that the first time they manipulated the polyamide film was 8 months before the flight module integration. So they soon realized that they had to turn the air conditioning off in the clean room just because the material would fly all over the place. And even moving too fast would make it unfold. So this definitely posed some challenges for the Gama team for sure. But then the special thing about the solar sail, apart from its size, is that it doesn't use any motors or deployable beams to stretch out the sail. It actually uses centrifugal force.
Okay, so what we're going to do is basically spin up the whole satellite and
yes.
It'll deploy the sail using...
It will deploy the diagonals, and then that will probably take approximately a week to deploy, only from the centrifugal force, and then the solar sail itself will unfold in less than 10 seconds once the strips are released, and will take its final shape.
If I remember correctly, a human hair is roughly 70 microns in thickness, so the sail that you mentioned is
Possibly.
2.5, so
Possibly.
roughly 30 times thinner than human hair.
That's really thin. That's hard to comprehend how thin that is.
Someone can check the math on that, but
Yeah.
it's pretty thin. Okay, and then speaking about solar sails, how do they actually work? Since we're taught that photons don't really have mass, and how does it propel the solar sail in space?
Yeah. So even though photons don't have mass, they still carry the momentum. So when the photon bounces off of the solar sail, it transfers some of its momentum to it, and that's what basically pushes it forward.
Okay. And then going over back to the launch, can you give us a brief introduction of where we're actually going today?
Yeah, so the payloads will be launched into a sun-synchronous orbit at around 525 kilometer altitude, with a mean inclination of approximately 97.6 degrees. And the payload deployment will start in around an hour after launch and should probably last for about half an hour.
Okay. Great, thank you. So with that, I'll just take a brief moment to go over the timeline of the event here. Now is about time to switch over to the SpaceX broadcast, where we will see the final countdown and launch of the Falcon 9 rocket. Once it enters into orbit and enters its coast phase, we will come back here to the studio to learn a bit more about the missions from our customers, take all that learned knowledge and apply it to a quiz where you can hopefully win some prizes. We'll have our talent acquisition partner join us here to talk a little bit about career opportunities at NanoAvionics if you wish to start your career in space. At that point, it'll be time to go back to the SpaceX live stream to see the deployment of the satellites. And once we see successful deployment of all 4 of our satellites, we'll come back here to the studio to hear a little bit from our satellite operations engineer of the first steps of actually getting contact with the satellites and beginning their operations. So with that, let's switch over to SpaceX and let's keep our fingers crossed for a successful and timely launch.
Nice launch trajectory. Pad is clear.
10, 9, 9.
Launch auto sequence.
Eight,
Launch auto
seven,
sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
One.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon separation confirmed.
Stage 1 is transonic. Landing like that deployed. And Falcon 9 has landed.
You are looking at a live view of Falcon 9 set to lift off at 9:56 a.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Happy New Year, everyone, and thank you for tuning in. I'm Shiva, and I'm the Space Operations Engineer here at SpaceX. And I'm joining you from our headquarters in Hawthorne, California. Today we are launching SpaceX's Transporter-6 mission, and as the name suggests, it's our sixth dedicated small rideshare program. Launch. This mission will mark our first launch of 2023 and our 200th mission of all time. On this flight are 114 spacecraft, including CubeSats, Microsats, and orbital transfer carrying spacecraft at a later time. We'll have a total of 82 deployment events, which will begin around the T+58 minute mark, last for approximately 30 minutes. Now we are expecting ground station coverage partway through the deployment sequence, so only some of the deployments will be visible today. However, when we're back in range of those ground stations, we do expect to have telemetry and hear audio confirmation over the nets. Now, if you'd like to see a full list of today's payload deployments, head over to SpaceX.com. With liftoff just about 6 minutes and 20 seconds away from now, let's take a moment to learn more about the Falcon 9 that's on your screen. Now, to give you a sense of scale, this Falcon 9 rocket is standing about 3 meters short of the height of the Taj Mahal in India. It was named after the Millennium Falcon from Star Wars, and it gets that 9 number from the number of Merlin 1D engines that are at the base of the rocket.
Stage 1 fuel load is complete.
What you see on your screen are the 4 key parts that make up the rocket. We've got the first and second stages, the black inner stage in between them, and then at the very top, the payload fairing. The first stage is the bottom 2/3 of the vehicle. We refer to it as the booster, and it's got those 9 Merlin engines that do most of the work to get it off the ground and into the thinner parts of the Earth's atmosphere. About 2.5 minutes into the flight, the first stage will separate and make its way back to Earth for a land landing at landing zone 1, which is on your screen. If you're keeping track, today's mission marks the 15th flight for this particular booster. Now, on top of the first stage, we've got that black carbon fiber inner stage. It connects the 2 stages, houses the pneumatic pushers that allow the first and second stage to separate during flight, and also houses the Merlin vacuum engine during ascent. On top of the inner stage, we've got the second stage, which is what's carrying the 114 spacecraft and will take them to their eventual destination in orbit. Shortly after launch, be sure to watch the
pressurizing for strong back retract.
Be sure to watch the velocity gauges that'll show up on your screen. You'll see how fast the first stage and second stages are going at separation, and you'll notice that the second stage continues to increase in velocity as we get to orbit. Now, the spacecraft are enclosed in the very top of the rocket in that large nose cone structure, which is called a fairing. Its job is to protect the satellites from the aerodynamic loads until we are out of the Earth's atmosphere, at which point the fairing will separate and expose them to the vacuum of space. You heard some callouts on the net there that we've begun pressurizing the tanks and begun pulling away the strongback. The strongback refers to that truss structure to the left of the vehicle, and we are just about T-minus 4 minutes to go until launch. Currently healthy on the vehicle and the payloads. Propellant loading is almost fully complete on the first and second stages. We've completely loaded fuel on both the first and second stages and are finishing up liquid oxygen loading on both stages. We'll hear a call out around the T-minus 3 minute mark for LOX load complete on the first stage, and a similar call out on the second stage around the T-minus 2 minute mark. Looks like an absolutely beautiful day in Florida. Based on the weather report, we're only tracking a 10% probability of violation. So that means that we are a 90% chance of go weather. But for whatever reason, if we were not to launch today, we do have another opportunity tomorrow at the same time.
Stage 1 LOX load complete.
So with that call out, liquid oxygen loading is complete on the first stage. We'll hear a similar call out on the second stage. Now, our goal with these missions is to provide small satellite operators competitive pricing, increased flight opportunities, and flexibility. We're flying some really cool payloads on this mission, including spacecraft designed to help monitor weather and environmental changes, as well as greenhouse gas emissions, spacecraft that improve communications for the Internet of Things, and those that also help measure and investigate galactic cosmic rays and solar rays. It's incredible how even the smallest satellites can make a meaningful contribution to the care of planet Earth and our efforts to visit other worlds. We are looking forward to providing a great ride to the 114 payloads on board today, just about 2 minutes from now. Next major milestone will be a call out for second stage LOX load complete. Once we hear that, we will be fully loaded on propellants for the launch attempt in about 2 minutes.
Stage 2 LOX load is complete.
So with that, we are fully loaded with about 1 million pounds of propellant on the vehicle. You'll see some clouds coming out from the vehicle. There they go. These clouds are coming from the transporter erector lines. The transporter erector provides the propellants to the vehicle. We're just clearing out the lines, and the cold oxygen that is in those lines ends up coming into contact with the moist Florida air and produces literal clouds around the vehicle. Coming up, next major milestone will be Falcon 9's transition into startup. That means that the flight computers on board the first and second stage will have taken over the launch countdown, and they'll continue to have control of the vehicle through the rest of the mission. Next major milestone will be the launch director giving their final go for launch.
Go for launch.
And with that call, all systems go for launch. Let's watch as this Falcon 9 takes the Transporter-6 mission to orbit.
T-minus 30 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff.
Vehicle's pitching downrange.
Stage 1 chamber pressure is now open.
We're just about 40 seconds into flight. Falcon 9 clearing the tower at Space Launch Complex 40 and making its way to orbit. We are currently throttling down the Merlin 1D engines on the first stage in preparation for the point of max Q. That's the point of maximum aerodynamic pressure.
Falcon 9 is supersonic.
Maximum aerodynamic pressure is the point when the highest stresses are experienced by the vehicle during the ascent.
Max Q.
And with that, we are through the highest stresses on the vehicle. Coming up, we've got several events back to back. The first of those is main engine cutoff, or MECO. There we'll shut down the 9 Merlin 1D engines in preparation for stage separation. Stage separation is where pneumatic pushers will separate the first and second stages. And then we'll have second engine start number 1. You just heard a call out for MVAC chill-in, so we've begun chilling in the turbopumps in preparation to start the Merlin vacuum engine on the second stage. While the second stage engine is burning, the first stage will be performing a flip maneuver, and then it will do a boost back burn. That boost back burn will ignite 3 of the Merlin 1D engines to make the first stage's way back towards land, since we are attempting a land landing today with this first stage. So again, those events back to back, MECO, stage separation, first stage flip, second engine start number 1, and then the boost back burn.
Stage 1 shutdown.
Stage separation confirmed.
Invac ignition.
Stage 1 boost back startup.
So there is those 5 events. Awesome shots from the ground. You can see the first stage boosting away. That was on the left part of your screen, and the second stage continuing to burn. Now this burn on the first stage will last about 47 seconds. And the second stage is going to continue burning for a while. It will complete its burn until the T+8 minutes and 20 or so second mark. Shortly after the boost back burn ends, the next major milestone will be fairing separation. You'll see that on the right-hand side of your screen.
Stage 1 boost back shutdown.
So there is successful shutdown of the boost back burn. You're seeing some pulses there from the ground from our attitude control system. We use nitrogen gas as our attitude control medium, and it helps us keep pointed in the correct direction. Here you can see the bursts firing on the first stage on the left-hand side of your screen, as we are also deploying our grid
Fairing
fins.
separation confirmed.
On the right-hand side of your screen, you just saw fairing separation. We may get a view of those fairing halves. In fact, you can see it on the right-hand side of your screen, just behind the Merlin vacuum. Heading back to planet Earth, we will be attempting to recover both of these fairing halves once they land back in the water on a recovery vessel named Bob. Now, if you're just joining us, welcome. We're about 4.5 minutes into today's mission. We're in the first of 2 Merlin vacuum burns. First burn will last until about the T+8 minute and 20 second mark. Next major milestone will be the first stage's entry burn. First stage is on the left-hand side of your screen. And we're now looking at a view down the body of the first stage, past 2 of the grid fins back at planet Earth. Now we execute the entry burn in order to slow down the first stage before hitting the densest parts of the Earth's atmosphere.
Vehicles are on a nominal trajectory.
Without that burn, we'd be only using the atmosphere to slow down the Falcon 9, and that puts a lot of extra stresses on the rocket. So we ignite 3 of those Merlin 1D engines to slow down as we hit the thickest parts of the Earth's atmosphere. We had an on-time liftoff, 9:56 a.m. Eastern Time, from Cape Canaveral Space Force Station. And we're carrying the Transporter-6 mission on the second stage right now. It's SpaceX's 6th dedicated smallsat rideshare program and our first mission of 2023. We're targeting at least 3 dedicated rideshare flights to sun-synchronous orbit per year. And we also offer opportunities to ride to orbit on our Starlink missions, which launch about once a week. Now, these small sats can ride to space on our Falcon 9, Falcon Heavy, and the Starship vehicle in the not-too-distant future. You can see that the grid fins have deployed on the first stage. We've got 4 of these hypersonic grid fins near the top of the stage. And once we get into the thicker parts of the atmosphere, it's only the grid fins that do the steering. To make our way back to landing zone 1, you can actually see the Space Coast of Florida there on the left-hand side of the screen. Next major event coming up in about 15 seconds. That's the first stage's entry burn, but will ignite 3 of the Merlin 1D engines.
Stage 2 FTS has safed.
Now keep an eye on the speed of the first stage in the lower left corner of your screen. You'll see that
Stage 1 entry burn startup.
drop off dramatically as the entry burn is slowing us down. pretty quick burn. This one will last about 20 or so seconds.
Nominal trajectory.
Stage 1 entry burn shutdown.
And there is successful shutdown of those Merlin engines. Now, as we are slowing down, re-entering the Earth's atmosphere, if you're in the Florida area, you may hear some sonic booms.
Stage 1 FTS has safed.
We are attempting to recover this booster for the 15th time today, targeting this landing at landing zone 1. We've got just one more burn, which is the landing burn on the first stage. We'll ignite just a single center Merlin engine. That'll happen just before touchdown.
Stage 1 transonic.
On the right-hand side of your screen, we've got a ground view of stage 1. You can see the center engine
Stage
has
1
ignited.
landing burn.
We'll expect to see the 4
Stage
landing
2
legs
terminal
deployed
guidance.
for a soft touchdown at landing zone 1. Now, during this, we'll also hear a call out of second engine cutoff on the second stage.
Stage 1 landing leg deploy.
Seco.
Stage 1 landing confirmed.
So landing is complete. We also heard a call out there for Seco.
Nominal parking orbit.
Seco is second engine cutoff number 1. We just heard a call out as well for nominal parking orbit. And with that, we have landed the Falcon 9. It's our 161st landing of an orbital class rocket. This booster's 15th. Now coming up, our next major event will be in about 45 minutes. That is for second engine start number 2. And that'll be followed shortly by payload deploy of the first 35 payload deployment events. So we're gonna leave you with views from space, and we'll see you back shortly for second engine start number 2.
Expected loss of signal. Cape.
Hello and welcome back to the NanoAvionics broadcast of the SpaceX Transporter-6 rocket launch. I'm pretty happy to say we've seen successful orbital insertion of the Falcon 9 second stage. And of course now we entered the coasting phase, which will last around 45 minutes, which in this time we will go over some of the missions flying on board that we've worked on with our customers. And we'll have our launch quiz as well as a Q&A with our talent acquisition partner. So first of all, congratulations to our customers who are now successfully in orbit. But of course, what we're really looking for is the successful deployment of their satellites and later on signal acquisition and control of the spacecraft from our Satellite Operations Center. So as I mentioned, first we're going to hear a little bit more from our customers about their missions. And the first one we're going to hear about is from Gama regarding their Alpha satellite. So Gama is a company in France who is building a commercial solar sail, commercial off-the-shelf component, which is a solar sail for organizations and businesses to use for their deep space propulsion needs. So solar sails work without any propellant needed for the spacecraft on board. They are solely pushed by the radiation pressure of the sun, and hence they don't need to carry any fuel for the satellite to reach distant destinations. The satellite we've built for Gama is based on our 6U satellite bus, which is roughly the size of a shoebox. And the fun thing about it is that Gama fit almost a 74 square meter solar sail, 73.3 square meters to be exact, inside of that tiny box. That is comparable to a 2-bedroom sized apartment. And let's hear a little bit more about that mission from Gama personally.
Hello, I'm Louis de Bouillon-Matignon. I am Gama's co-founder. Gama is a French-based company aiming at revolutionizing deep space transportation thanks to solar sailing. We are flying our first mission, Gama Alpha, in low Earth orbit with NanoAvionics, and we will deploy a 6U CubeSat in low Earth orbit that will deploy a 73 square meter solar sail. Our project with Gama is to revolutionize deep space transportation and to basically take payloads from point A to point B with a solar sail without any fuel.
What is a solar sail? A solar sail allows a spacecraft to be accelerated purely from the sunlight, from our sun. Photons bounce off a reflective surface, and in reflecting off the surface generates a very light force that creates a constant acceleration. That constant acceleration, in the absence of any friction in space, allows us to pick up speeds that are unimaginable today. And most importantly, it allows us to accelerate without using fuel, therefore dramatically reducing the cost of access to deep space. And that's the revolution that we're building with Gama.
Before going to deep space, we first need to validate our deployment methods. Gama Alpha is a 6U CubeSat to be launched in a Falcon 9 SpaceX rocket at an altitude of 550 kilometers to validate these deployment methods. The first step of the mission will be the commissioning. We will first validate and test that all the subsystems are fine after the launch. Right after that, we will deploy the 73.3 meter square solar sail. One of the main challenges of solar sailing is to control those huge solar sails with a small CubeSat in the center. This is why the third step of the mission will be to validate our control algorithm and to check that the model fits the reality. At the end, with this huge surface, the satellite will deorbit naturally.
Of course, we have many people to thank, most notably the team who've been working relentlessly building our first mission, the French Space Agency, the CNES, NanoAvionics, SpaceX Launch, and many, many others who've been helping us along this journey. I'd also like to give a special word to our sponsor, CGM, a global logistics company based in France with huge ambitions, not only on Earth, but also in space. So we're delighted to be working with them, and I think we have a lot to learn from them, as I hope they do from us. So thank you very much for following. If you'd like to work for Gama, There's some open positions on the websites, and thank you for following us and supporting us so far.
So that was Gama's Alpha satellite. I'm really looking forward to see that sail deploy. I know the satellite has 4 cameras on board to capture the deployment and monitor the health of the solar sail during its mission. So hopefully we get some incredible views from Gama. For the next mission, we're looking at MilSpace 2, which is a consortium of Norwegian and Dutch research centers, so FFI, TNO, and NLR, who are aiming to measure radio frequencies and geolocate radio signals on ground. And for that, you might, if you're looking closely at the satellites, you might see some differences between Gama and MilSpace. So the first one you might see is that MilSpace satellites are missing this so-called tuna can on top of the satellites, where we typically house maybe batteries or reaction wheels or some other subsystems. But instead of that, the Birkeland and Huygens satellites have an electric propulsion system on board. So the whole principle their mission is based upon is that the satellites use formation flying to basically detect and measure the differences of the angle of arrival and time of arrival of those signals between both satellites to give them enough data to precisely geolocate signals coming from ground. And to hear more about that mission, we can also now look at a quick video from MilSpace.
We live in a world where geopolitical tensions are growing. The security situation in Europe and elsewhere in the world is becoming more complex. Maintaining awareness of emerging threats is rapidly becoming more challenging. In order to protect our societies, our countries, and to counter threats in military operations, it is important to keep ahead of these evolving threats. Utilizing the right information is essential, and using the space domain is crucial to retrieve information in a timely manner. By using new satellite systems and new emerging technologies, we are able to gather more detailed information and get a better understanding of what we are facing. This is why Norway and the Netherlands, 2 like-minded NATO nations, have joined forces in a research mission. Together, we have succeeded to create a capacity that can observe radar systems on land and at sea, the MilSpace 2 satellite system. These 2 satellites, Birkeland and Huygens, work together in formation to better detect and improve geolocation. By working together, combining our knowledge and experience in this research mission, we have demonstrated a unique and vital capability as a foundation for future operational capabilities. We rely heavily on space technology in our daily lives. Space is important both for economic reasons and for our security. Through the MilSpace project, we have shown how new technology provides new opportunities. These satellites can give decision makers a better situational awareness, and therefore we see this project as an important step towards protecting our societies and our values.
The MilSpace 2 mission are 2 6U CubeSats flying in a formation. It's a collaboration between FFI from Norway and TNO and NLR from the Netherlands. TNO, NLR and FFI are building the instrument, and we have also a collaboration with NanoAvionics that builds the platforms. My name is Bert-Johan Volmeler. I'm working for the Royal Netherlands Aerospace Center, NLR, in the Netherlands. And I'm the lead system engineer for MilSpace 2. This project has a very high density or a high dense integration between the instrument and the platform, which was very hard to achieve. But because we cooperated with NanoAvionics in a very detailed way, I should say, with many video calls, we could establish this high density combination of instrument and platform. It was a very nice project to do. The instrument is a spectrum monitoring system. So we try to monitor all the RF spectrum once it's in space, especially radars, like shipnet radars, but also other kinds of radars. And of course we are looking very forward to the launch. Hopefully everything will be successful. And we are very excited to see the first results and what the instrument finally will be capable of.
So we're looking forward to what the Millspace mission is going to achieve as well and how the payload will perform. But now we have roughly 30 minutes left in the coast phase of the Falcon 9 second stage, which means it is about time to start our quiz. So we had quite a bit of information there from Gama and from Millspace to digest, and now we'll see how much of that you have retained. So I would like to have you join our quiz over at ahaslides.com/zhajj. You should be seeing the screen for the quiz on your main screen with the address and a QR code to scan. So please start joining the quiz. First of all, you'll need to enter some contact details in order to participate. This is just so we know who to contact to deliver the prizes if you are one of the 5 winners. So the prizes contain some of our NanoAvionics space merch, including our well sought after space socks. And the rules of the quiz are fairly simple. We'll have 12 questions in total. Each of them have 4 or 3 answers to choose from. And after every 4th answer, we'll have sort of a leaderboard to see where you are to check in. Some of the questions might have 2 correct answers, and you are basically rewarded extra points for how quickly you can select the correct answers. Keep in mind, we might have a slight delay in the live stream, up to 5 seconds perhaps, so do keep your eyes on your tablets, your smartphones, or another browser on your laptop to read the questions and select the responses. So what the questions I will be reading might be a little bit delayed from the questions you are seeing on your screen. So after this short quiz, we will have an interview with our talent acquisition partner, Julia, as mentioned before, and then it'll be time to go back over to SpaceX to see the satellite deployments. So now I'm just dragging the time a little bit to allow more of you to join, but I can see we have over 50 participants joining us at the moment. If any of you are interested in working in the space industry on some cutting-edge commercial satellites in the new space industry, you are welcome to check out our careers page on our NanoAvionics website after the show, where we have an updated list of the current positions open in US, UK, as well as Lithuania. We are hiring, we have plenty of open positions for engineers as well as all other kinds of people. So with that, I think we might be about ready to start. And we can maybe move on to the first question now. And we're going to start fairly simple with orbital mechanics, of course. So what mean inclination are our satellites going to today? Is it A, 97.5 degrees, B, 95.5 degrees, C, 92.5 degrees, or D, 95 degrees? The orbital inclination measures the tilt of an object's orbit around a celestial body. So imagine if a satellite was orbiting the Earth around the equator, it would have a 0-degree inclination. Since we are going to sort of a polar sun-synchronous orbit, you already see that we are above 90 degrees, but let's see if you answered that correctly. So the correct answer was 97.5 degrees-ish. Might be a small error there. But we can move on to the next question now. And it is regarding Gama's solar sail. So how large is the solar sail on Gama's Alpha satellite? Is it A, 73.6 square meters, 76.3 square meters, 73.3 square meters, or 72.6 square meters? It is roughly the size of a 2-bedroom apartment, and it deploys from a satellite that is basically the size of a shoebox. So you might have already heard how incredibly thin it is, roughly 30 times thinner than a human hair, if I'm correct. And we'll be hopefully able to see that sail deploy in orbit soon. And the correct answer was roughly 73.3 square meters fit inside this tiny 6U nanosatellite. And let's move on to the next question, which is regarding the harsh environment of space. So who is responsible for calculating whether a satellite can survive in the vacuum of space? Is it testing engineers, simulation engineers, system engineers, or project engineers? Of course, there's a lot of environmental challenges regarding spaceflight for satellites. You have a vacuum, you have constantly changing temperatures going from one extreme to the other extreme as you go from sun to eclipse. And someone needs to figure out whether the satellite and all of its materials will actually handle that heat. And that is a job for the simulations engineers, who basically have digital twins on ground and simulate how these satellites are going to act in space before they are even deployed. And we can go to our fourth question, after which we will see a leaderboard for the first time. So which of these systems are on board the Millspace 2 Birkeland and Huygens satellites? Is it A, X-band transceiver, B, an S-band transceiver, C, a star tracker, and D, a propulsion system? You can sort of see them in the background, and you might be able to see some of them. And of course, my colleague, my technical sidekick for the night in the beginning of the broadcast mentioned all of these subsystems. So let's see. It was not bad. Of course, all of the answers that were correct, and quite many of you got them right. So we can move on to the leaderboard and see who is actually at the top at the moment. Okay, we have a top 5, and let's move on to question number 5, which is how many satellites are in total on board the Transporter-6 mission today? Is it A, 116, B, 114, C, 124, or D, 119? Of course, we personally have 4 satellites flying on board that we have built for our customers. Gama, the Millspace Consortium, as well as another customer that would like to be disclosed, but there were quite a few more rideshare satellites on board. And as you can see from the possible numbers, it was quite a packed Falcon 9 mission. And the correct answer is 114. So let's move on to the next question. And I've mentioned that the Gama satellite will have a couple of cameras rotating, which you can see filming the satellite, which you can see in the picture. But what is the rotational rate that the Gama's Alpha satellite will need to achieve before deploying its solar sail? So as we mentioned, the satellite will not use, or Gama's payload does not use any motors and deployable beams to actually stretch out the sail. It is basically going to spin the satellite at a certain rate to use the centrifugal force to stretch out the sail and deploy it that way. And the correct answer is that it will it will need to be spinning at around 8 revolutions per minute. Sorry for those who didn't answer that one correctly, but let's move on. You can maybe do better on the next one, which might be easy. So, is this a real picture taken by a NanoAvionics satellite a few weeks ago? And the options are yes, no, but where are the stars? As option C. I think that appears to be Italy there in the background. Some lightning bolts beneath the satellite. And of course, this was a trick question because there were 2 correct answers, both yes and but where are the stars are correct answers. So if whether you answered one or both of them, you still get some points. So let's move on to the next one, which is, while flying in formation, what distance from one another will the Millspace 2 Birkeland and Huygens satellites trying to maintain? As we mentioned, they're flying in formation, so will they be at around 20 kilometers between one another? B, less than 10 kilometers from one another? C, less than 5 kilometers? Or D, less than 3 kilometers from one another? Of course, they'll need to do that in order to measure the difference of the arrival of the signals they're trying to measure from ground, as well as the different time of arrival to conclude any specific locations of those signals emitted. And the correct answer was around 20 kilometers from one another, plus minus 5 or so kilometers. And let's move on to what I believe is the 8th. Oh, okay, we have a starboard at the moment. So we have a top 5. I think it changed a little bit from last time, so let's see how this will end. We have a last batch of 4 questions ready, and the next one is: which type of heat dissipation is not possible in the vacuum of space? Is it A, conduction, B, convection, C, radiation, or D, all of the above are possible in space? Of course, keep in mind space is more or less in a vacuum, or at least we're talking about space as a vacuum in this case, which is what our satellites experience. And of course, these heat dissipation is a major problem we need to solve when designing satellite missions in order for them not to overheat or be too cold in space. And many of you actually answered correctly that it is convection, since there is no air in space in a vacuum for the heat to travel through. Moving on to the next question, which is something we've mentioned before as well in the intro. So which of these systems does the Gamma Alpha satellite not have? Is it a S-band transceiver, B, a star tracker, C, an electric propulsion unit, or D, magnetorquers? So at the beginning of the broadcast, we discussed these differences between the Birkeland, Huygens, and Alpha satellites. They are both the same size essentially, but their mission requirements differ, and for that reason they have different systems on board. And Gamma Alpha actually doesn't have any star trackers and electric propulsion unit. It does have S-band to communicate and transmit data back down to Earth, and it does have also magnetorquers in order to make sure that the satellite is able to keep its orientation in space using the magnetic field of the Earth. And we have our second to last question next. Which reads as: which countries are participating in the Millspace 2 program consisting of the Birkeland and Huygens satellites? Is it A, Norway, B, Germany, C, Netherlands, and D, Belgium? I'll give you a hint here that since it is a consortium, there are at least 2 countries participating in it. And the mission is of those countries' research centers. And the correct answers were Norway and the Netherlands. So the FFI from Norway and TNO and NLR research centers from Netherlands are both collaborating on the mission. And I think we are down to our last question. So after this, we will see our winners. And how many cameras does the Gama Alpha satellite have for capturing its solar sail deployment in orbit? Is it A, 2 cameras, B, 3 cameras, C, 4 cameras, and D, 6 cameras? As I mentioned, this is one of the items I'm looking forward to see coming back down from that satellite once we validate the solar sail is deployed successfully, actually seeing it unfurled in space and maybe even some of the moments of it unfolding. That would be quite a sight to be seen. And great, most of you actually answered it correctly. There are 4 cameras on board, and hopefully they all work and deliver some nice visuals. So now let's switch over to the leaderboard and see who won their prizes. Nice, congratulations. So these top 5 winners will be contacted by us via email that you provided when registering for the quiz. That will probably take place in the next couple of working days, and we'll ask you where we can send you your prizes. So thank you for participating. Quite well done, I should say, and thank you for listening. And now I would like to return back to our studio where we have our talent acquisition partner, Juliana Rikita, to talk a little bit about what's it like working at NanoAvionics. If any of you are interested in joining the new space industry and work on some cutting-edge commercial satellites, this might be a good opportunity to learn about what's it like working here at NanoAvionics. So thanks for coming along, Julia. Nice to have you here.
Thank you, Sharunas, for inviting. Good evening, everyone. And yeah, I'm glad to be here.
Great. So just to start off, maybe we can give a refresher for the audience. What does NanoAvionics actually do?
Yeah, so basically we're a nano and small size satellite manufacturer. We've been in the market for a while, for more actually than 8 years. We've been one of the most leading companies in the nano satellite industry, and we actually grew a lot. We have 4 open offices, because 2 of them are in Lithuania, Vilnius and Kaunas. US is in Maryland, and the other one is in UK, in Basingstoke.
Okay. So, and what are our goals for the 2023 in terms of
growth?
Growth, yeah.
Okay, so basically, the past years were really exciting. We grew exponentially. We actually onboarded so many people, and I think the upcoming year will be also, we definitely have some goals, and we will be onboarding, of course, new people and looking for new hires. So we're quite open for the new candidates, especially for engineering team. So the headcount will definitely grow.
And I guess the space industry can have sort of a stigma around it a little bit, that there's a huge entry barrier, and you need to be an aerospace engineer to work in the space industry, and you need to be a rocket scientist. But is that actually true, or not really?
Yeah, I don't think that you need to be an aerospace engineer to work in this industry. You will find so many people working here in NanoAvionics who are coming from different backgrounds. They're coming from the financial industry, they're coming from other defense or any other manufacturing companies. You will also find people from IT backgrounds. So I think if you really have that passion, if you want to really come here and gain the experience and knowledge, because we do have that within the company. So we always say, yes, let's try and let's give it a shot. But of course, the engineering background at some point for certain positions is definitely required.
I think the space industry has been changing a lot as well, going more and more commercial, which maybe opens up more possibilities for other people who have not been necessarily trained as aerospace engineers, especially in the less engineering savvy positions, if I can say
exactly.
so. And talking about that, what are our plans for 2023 in terms of hiring, growing, expanding our team?
Yeah, so as I said, we will still grow. We will definitely be looking for engineering. Like we have a goal to be always on track, to always deliver results and deliver projects that we already signed. So we're always making sure that we have sufficient number of employees. So we will definitely hire. Maybe not such a growth as we used to have the last year, but definitely there are plenty of positions that you can already see in our career page.
Yeah, and coming from your own perspective, anything special you feel yourself working here at NanoAvionics and in this growing new space industry?
Yeah, I think that talking from the company perspective as an employer, I think you can always say that we have certain benefits and perks, but I think this is not the main advantage that we have. The main advantage that we have is people that are working over here. Yeah, and they are very smart. You will find so many passionate people about the space industry, the ones who are really motivated to actually build the satellites and see their results up there in space. So I think the cultural aspect is definitely a competitive advantage over here, and yeah, the people here are young, enthusiastic, and they have always new initiatives, ideas, and I think that will help succeed our company as well.
Great, and then do you have any immediate open positions at the moment that we need to fill? Who should be contacting us?
We have a bunch of them you will find on our career page. I think the most important to mention is, of course, engineering. Engineering team is always on a search. And as I say, our talent acquisition team is always on a search and hunting people. So yeah, there we will find plenty of them. And we're looking forward for new candidates. And yes, during the year, of course, when an engineering team grows, we also need more commercial-related positions, also administration-related positions. So you need to be updated and look after our career page to make sure that you find the right spot for you.
Do you have any top lists for UK, US, and Lithuania?
Yes, definitely. In US, currently, we're looking for a BD manager. We also
business development?
Business development manager, a salesperson who could actively do the sales, project engineering, more on a technical aspects focused, and with the projects working, and also project manager. In UK, you will find, we always looking in UK, definitely, so you will find mechanical, simulations, you will find, what else, electronics engineer, you will find also satellite operations, so definitely plenty of them. And in Lithuania now currently, project engineering, assembly, and simulations also the key areas where we are looking for candidates.
Great. And due to the couple of recent years we've had, I think remote work is becoming more and more important to people.
Yeah.
How do we deal with that? Can people, if they're not in the US, UK, or Lithuania, can they still apply to some positions that maybe don't require hands-on work?
Yeah, so it's a really good question. I think we have that advantage for certain positions, definitely. Those positions who actually need to be here on site. Unfortunately, we cannot offer that, but we have a very hybrid and relaxed, I think, attitude towards that, approach towards that. So we can also work remotely. Some of our employees are working partially 50% there, 50% on site, 50% online. So It's a hybrid. So it really depends on the position, on the site, and then the scope of responsibilities that you carry.
Cool. And if this all sounds great to somebody watching us, how do they get in contact, and what is sort of the process for getting into NanoAvionics?
Yeah, so we're glad to have 3 more people on talent acquisition team. So we're now reaching to our candidates pretty fast. So you can always apply through, like candidates always can apply through our career page or reach out on LinkedIn. So our ladies are very responsive. So there are a couple of stages that you need to go through, but the first step is the phone screen. The second one would be the interview with the hiring manager and talent acquisition person. Depending on your role, there could be also a homework assignment, and also there could be the last interview just to double check with the head of department. And then if everything goes well, we're happy to onboard and send the job offer.
Great. So thank you, Julia.
Thank you.
Thank you for watching. If you do want to work with us, you feel free to head over to our web page, nanoavionics.com, and visit our careers page. As Julia mentioned, the positions open are updated, and last I've seen there's quite a few of them open, so grab them, I guess. And with that, I think it's about time for us to switch back over to the SpaceX broadcast. We should be seeing the satellite's deployment in a few minutes' time. Just to give you a sense of what's coming next, we will switch over to the SpaceX broadcast to see that deployment. It should take around maybe 10 to 15 minutes. After that time, we will return back to our studio for sort of final confirmation of the deployment. And we'll also hear from our satellite operations engineer about sort of the first steps of getting contact with the satellites and operating the satellites and basically beginning their mission. So once SpaceX's job is done putting satellites in orbit, our satellite operations engineer's job basically just begins, sometimes taking years working on these missions from our customers if we are doing the mission operations for them. And of course, after that, we will sign off for the evening. So for now, let's head over to SpaceX, and we will be back in the studio shortly with you. Thank you.
Acquisition of signal, reef.
We sat there in 25th century AD. We sat there and looked at a rocket from Mars, and you just boggled the mind. And the technology caught up, didn't it?
Acquisition of signal, Maldives.
Welcome back to our coverage of the Transporter-6 mission. We've had a great mission so far. We lifted off on time at 9:56 a.m. Eastern, recovered our first stage at landing zone 1, and completed the first of 2 second stage burns. Now we're coming up about 20 seconds away from a quick reignition of our Merlin vacuum engine. This burn will just be 2 seconds to circularize our orbit. So coming up, second engine start number 2. And there is successful startup, SES-2, as well as second engine cutoff number 2.
Nominal orbit insertion.
With that call out from mission control, we are in the expected orbit. Now, as I just mentioned, you are watching the Transporter-6 mission. This is our 6th dedicated rideshare mission and SpaceX's first mission of 2023. The Falcon 9 lifted off at 9:56 a.m. Eastern Time from Cape Canaveral Space Force Station in Florida. We successfully separated the stages, landed that first stage at landing zone 1 for our 161st recovery of an orbital class rocket, and we just completed the second of our 2 planned second stage burns. If you're not familiar with our transporter missions, they are dedicated rideshare flights. SpaceX is targeting at least 3 sun-synchronous orbit missions per year, in addition to various opportunities for a ride on our Starlink missions, which launch about once a week. The small sats can ride to space on our Falcon 9, Falcon Heavy, and in the not-too-distant future, Starship. Now, we've got 114 spacecraft, including CubeSats, PicoSats, Microsats, and orbital transfer vehicles carrying spacecraft to be deployed at a later time in the mission. And as I mentioned earlier in the webcast, we are flying some payloads that are really cool to help monitor weather, environmental changes, greenhouse gases, satellites that improve communication for the Internet of Things, and satellites that will measure and investigate galactic cosmic rays and solar rays. Now, for the 114 spacecraft, there will be a total of 82 deployment events. Those will happen just past the T+58 minute mark, so just about a minute from now. And the payload deployments will last approximately 30 minutes. Now, unfortunately, we only have partial ground station coverage for the deployment sequence, and the ground stations are how we get our telemetry and these live views of the second stage. So we won't have coverage of all of the deployments visible today. But once we get ground station coverage back on the other side of that blackout, we'll expect to have telemetry and hear audio confirmation of the payload deploys that'll occur during that period. It's also worth mentioning that because these spacecraft are being deployed in groups in quick succession, we may not be able to confirm every deployment in real time. While you will hear most of the callouts by our mission control operators, we will try to provide updates for any that we don't hear real time by the end of the webcast. We do have a full list of the payloads on SpaceX.com if you'd like to follow along. But for now, we're going to listen in as the payload deployment sequence is about to begin.
Wait, Sat-1, separation confirmed. BD Sat-2, separation confirmed. 2, immaculate, separation confirmed. Lemur 2, Fuententaja, 01, separation confirmed. Connecta T1.2, separation confirmed. Gamma Alpha, separation confirmed. Bro 8, separation confirmed. Newt, separation confirmed. Huygens, separation confirmed. Lemur 2, disclaimer, separation confirmed. Star Vibe, separation confirmed.
Lemur 2, Steve Albers, separation confirmed. ISI launch Cleos KSF3A, separation confirmed. Birkeland, separation confirmed. Space B 156, 167, separation confirmed.
Expected loss of signal, reef.
Lemur 2, M Molo, separation confirmed. ISI launch Cleos KSF3B, separation confirmed.
Hello and welcome back to the NanoAvionics broadcast of the SpaceX Transporter-6 mission launch. where as a small satellite manufacturer and mission integrator, we had 4 satellites flying on board the mission. And happily, we can say that we saw the deployment of all of our customer satellites. So a huge congratulations to all of them, Gama from France, as well as the MilSpace 2 consortium, comprised of the FFI, NLR, and TNO research centers from Norway and the Netherlands. But of course, this only is the beginning of the work that we need to do. So as SpaceX finishes its job with our satellites, at least, our satellite operations engineers' work just begins. And for that, I actually have one of our satellite operations engineers here with me, Mindaugas Kazanavičius, to talk a little bit about sort of the first steps of now that the satellites have successfully deployed, and somehow we need to get contact with them and communicate with them. So thanks for being here, Mindaugas. Pleasure to have you. What are the first steps that your team will now have to perform?
Yeah, thanks for having me. So when the satellite now is released, now we're waiting for, we have like 4-hour silence period, and the satellites will not be transmitting anything. At the moment, the satellites are turning some subsystems, powering on, performing some internal checks. And after 4 hours, approximately, the satellites will start to deploy antennas and solar panels. And after that, they will start to transmit a beacon, a small signal with some telemetry data, and the operators will be catching the beacon. So that's the most exciting part at the moment, what we're waiting for. So the beacon, the small signal is transmitted approximately like once in a minute when the satellite is flying over the ground station. And so we are catching the beacon, parsing the telemetry, decoding it, and then engineers reviewing the data, and we double check the state of the satellite. We double check if the solar panels are deployed, antennas are deployed. We see what is the power budget, what are the temperatures and other parameters. And then after gathering initial data, we wait for one orbit when we have a next contact, and then we gather some more data and compare it with the previous one, so we can see what is the state in general of the satellite. And if everything looks good, then we're starting to change some parameters on the satellite. We may power on some additional subsystems, maybe some heaters, some other systems on the satellite. And in this new configuration, the satellite is flying for few orbits. Could be a few days, depends on the mission. So we're gathering more data, more telemetry. And again, our engineering teams, they review the data. And if everything is okay, we're again powering maybe some other subsystems, going into another configuration. And then we're reaching a LEOP stage. And so this is the stage where the satellite will be, in which we'll be flying for quite some time. And then we're starting to validate all the subsystems. So all kinds of attitude systems, payload controllers, and so on. And so all this process takes some time. Based on the mission, of course, it may vary a bit. And that's the most interesting part of all the missions. So in some cases when we have cameras, capturing first image, very exciting. We have some thrusters, if we have some thrusters, first time when we push the satellite somewhere, in our case with solar sail, again, deployment sequence, very interesting part. So the work for operators is just starting. And we'll be waiting for first contacts with the satellites and catching them.
Yeah, good luck with that. I hope we get it on the first try. Usually that's what happens, but I guess it's Important to mention that we don't necessarily know the exact location with very high precision where those satellites are being thrown off.
Correct.
So sometimes it's a little bit of a mouse and cat game to find exactly where those satellites are in space.
Correct, yeah. And it also depends, the first contact, what elevation, on which elevation the satellite is flying. So, if the satellite is just above the horizon, so the contact will be weak. If it's flying above the ground station, of course, the signal is strong, so it's easier to catch, to get the beacon and the data.
Yeah, and in general, what are sort of the challenges of communicating with with something that is flying in space?
The satellite is flying quite fast, around 6-7 kilometers per second. So you have to track quite accurately. Of course, you have the UHF system, which you don't have to be very precise when tracking the satellite. So on the UHF system, you can get low bandwidth data rate, but you can get the signal. When you want to use like S-band or X-band, you need to be more precise with the satellite. You have to point directly at it. So yeah, it's a bit tricky to find the satellite, especially at the beginning, when the satellites are released and you have approximately the position. Eventually, when you know the position exactly, it's technically quite easy when everything is working to communicate with the satellite. And when you have many ground stations all over the world, so it's really fun actually. So yeah, you can just the notion, you send a command which flies 500-600 kilometers into space and gets back to you, and you have the result. That's awesome. That's the work what we do.
Great. Well, thank you for your insights, and good luck with catching and getting contact with the first satellites tonight, I guess.
Thanks.
And for the rest of the audience, if you feel that working on satellites is something you would like to do as well, as mentioned before, we have a lot of open positions over at our careers page, so you're welcome to check them out as well. And lastly, I would like to congratulate our customers for getting into space a second time. Well, I'd like to congratulate them a second time for getting into space. If you wish to follow the updates on these missions, both on the Gama Alpha satellite, which carries the first European solar sail mission into orbit, and how its deployment sequence is going to turn out, you can follow us on social media or any of our clients like Gama Space, FFI, NLR, and TNO for those updates. Of course, since we had a quiz before in our webcast, we will also be contacting the winners of that quiz to send out you the prizes, which will happen in the next couple of working days. And with that, thank you very much for watching, being with NanoAvionics. We wish you a great 2023. It turned out to be a pretty good kickoff to the year for us. And we will see you next time at hopefully at another launch. Thank you.
Thanks.